And today we are going to talk about alternating currents, AC circuits, the current which flows in all your electrical appliances which are there in your house. And you will see that it is slightly different from the direct current, in which the current only flows in one particular direction. The current which flows in your houses continuously changes the direction. And long time back, people thought that AC current is dangerous. In fact, Edison was one such businessman who said that it's the DC current which is safe, and there used to be regular wars, just like you have wars between Apple and Samsung for patents. There used to be, yes, tough wars between Edison and Tesla long time back. Tesla was a firm believer of alternating current, and we know today that AC is much better, efficient, can be easily stepped up, stepped down than the DC current. And that's what we're going to see with me, Shreyas, your master teacher for physics at Vedantu, going live. How are all my minions? Come on, let me know in the chat box. Come on, hit all your feelings in the chat box. I'm going to read it. Hello Yalini, VK, Science Priya, Vasudevan, Aishwarya, Science Priya, Darshini, Albert, Kirito. Welcome Shreya. Hello everyone. How is everyone? Yes, good. Are you guys doing good? So I hope you guys just saw the video which I just uploaded. If you haven't, please check it out. It is just a 50-55 seconds video. You can check it out on our channel in the past videos and let me know how it was. And I'm hoping that you guys are going to enroll into that course of IE Irodov, which is a very important course to make sure that your preparations can scale up to the next level. The link for that is also there in the description box, and even on the screen. If you click that I button, you will get that link. All right, and every other detail will be told to you in the course as well. So how is everyone? Yes, Ramesh Babu, Ankit. All right. Acha, Ankit, definitely I'll post I cannot post the book link as such because there is no PDF. I mean, that would be illegal to do. But if you want to buy it, you can definitely buy it on Amazon. Hello Maruti, Darshini, Nadwa, Princey. Welcome aboard. So guys, this is Shreyas here, like most of you know, but in case you are new, I'm pretty sure by now you have read about me, and I hope you're going to follow me regularly. And do not forget to check out my Instagram profile as well, Shreyas_Vedantu, alright, where you can get in touch with me, you can tag me, and you can see all the latest updates about me out there. And before we start, I hope you are going to smash that like button, and I hope all the new users who have not yet become our members are going to hit that subscribe button out there. Go ahead, hit that subscribe and smash that like button out there. Alright, and share the joy of learning with all your friends so that they also get the benefit of this channel, which is in English. Alright, hello Yavar, welcome aboard. Hello Priyanka, thank you. Okay, so this is the schedule for this week. We have started with thermal physics. Today we are going to talk about AC and LCR circuits. We'll continue with thermal physics in a marathon session, where we're going to talk about different thermodynamics related problems with previous year questions. Tomorrow is a very special session. Do not forget, it's just going to be there for 5 to 10 minutes. So if you come at 7:20 or something, maybe you might not find me. So make sure you are there on time. 7 o'clock tomorrow, the most important and expected topics in physics. So I'm going to talk about it. And Saturday, previous year's questions, mock test, most expected questions from NTA Abhyas. I'm going to prepare a mock test for all of you, and we are going to give it to you well in advance, and we're going to discuss it, and these are the most expected questions. So do not forget to check that session out as well. So let's begin. And first, of course, to start with AC, the first thing that we need to do is talk about how AC is generated. Now remember that Faraday said that when you have a loop, and that loop, all right, is placed in a magnetic field where the field is changing, or maybe somehow you change the orientation because of which the flux changes. So remember this, the change in flux through a coil, all right, that creates induced EMF, and that is what Faraday told. And using Faraday's equations, one can easily derive this. If you take a coil, all right, it has some area, it has some number of turns out there, and it is placed in a magnetic field. So take bar magnets, so that bar magnets will create magnetic field, and you rotate that coil in that magnetic field. What will happen? Certain times there will be no flux passing through the coil because they are just going to go over the plane of that coil. As the coil rotates, some of the field lines will intersect the coil. As it rotates more, you will see more field lines will intersect, and again as it rotates even more, then you will see less field lines intersecting it, and as it rotates more, again no field lines will intersect it. Again when it rotates, more field lines will intersect, and this cycle will continue. So you will see that the number of lines piercing through the coil will continuously be changing as the coil rotates about its axis. Who is going to rotate it? Not a motor. Understand? You need some other thing apart from motor, because remember, our intention is to generate electricity. So it's not rotated by a motor, it's either rotated by a turbine or some engine. So if it's a diesel generator, the generator will rotate it, the diesel engine will rotate it. If it's a turbine, most likely it will be rotated because of the water falling from a great height. The water's potential energy will be falling on the turbine, which the turbine will rotate in turn, and in turn the coil will rotate. So that is hydroelectric power. So this is what happens in a power station. So the coil rotates because of some other form of energy rotating that particular coil. And because of that, the induced EMF which is generated, all right, that is given by B A omega n, and you can have either sine or cos, doesn't really matter, sine omega t. Now this is a very, very important formula. Now let me tell you what is B. This is the magnetic field which is due to the magnets out there. So it is due to the magnets. A is the area of that coil, okay, that omega which is there, that omega is the angular speed of the rotation of that coil. And what is n? It is the number of turns in that coil. More the turns, more the induced EMF. So this is a very important formula, can be easily remembered. Born, remember the word born, born sine omega t. Yes, Jason Bourne, alright, I'm pretty sure you would have heard about that movie or seen that movie, so something like that. But the spelling is slightly different, be careful. So born sine omega t or cos omega t, that's how it is. Now, what is another important thing that you should note over here is that this particular value which is there, that is B A omega n, this value is the max EMF, or basically it is the amplitude of voltage. And I'll tell you why. Because sine has a max value of 1. So whatever comes outside will become the maximum value of the EMF. So if the maximum value of this sine omega t is 1, this BA omega n will be the maximum value of this EMF. Please keep in mind, this EMF is a function of time. That means the EMF will be 0, sometimes maximum, sometimes 0, sometimes negative. You can see the sine value will oscillate between 0, 1, 0, minus 1. It will keep changing. So even this EMF will keep changing. I hope this is clear. So in fact, if one draws the graph of this, it looks something like this, where, you know, this particular value, this height which is there, all right, this height which is there, that will be B A omega n. Remember that. And this, you can see, is like a sine curve with amplitude of B A omega n. Sometimes it is positive, sometimes it is negative. And remember one more thing, this is the time period. This is the time period of that cycle, and that time period t is nothing but 2 pi by omega. We know that time period is 2 pi by omega. That's the standard result. From this you can also get the frequency. Remember, frequency of oscillation and time period are inversely related. 1 by f is t or t is 1 by f, one and the same thing. I hope this is all clear. Alright, RLN, the details of that course have been mentioned in the description box, so please check the description box out there. Okay, so t is 2 pi by omega by circular motion. Remember circular motion? Time period of circular motion is 2 pi by omega. That's how I got the time period. Standard result, Ankit. Alright, and even from SHM, in SHM, if omega is the angular frequency, time period is 2 pi by omega. Alright, cool. Great, great, great. Now, usually, alright, the frequency in your house which you get, the frequency in your house is around 50 hertz. Yes. So the generation which will be happening wherever, in your thermal power plant, nuclear power plant, whatever, that coil will be rotating 50 times in 1 second. This is the usual frequency in India. In US and all, it's 60 hertz. So it's a standard value so that everybody, has the same standard specification. Now, let's talk about some important parameters. Let's talk about some important parameters in alternating current. Very interesting fact to note in alternating current is that if this blue graph represents, look at this blue graph, if it represents voltage, then the voltage is continuously changing. Like you can see, this is the maximum voltage at any instant. This maximum voltage, that blue arrow mark that you see. The current flowing may not be simultaneous with the voltage. That's the strange part, and that can happen because of capacitors or inductors and resistors which are there in the circuit. So your household items may have some capacitance, inductance and resistance properties, because of which there is some phase difference, and you can see the current graph is not in sync with the voltage graph. So you can see that there is a phase difference between the voltage and the current. So say for example, if the voltage graph is something like E naught sine omega t, alright, if the voltage graph is E naught sine omega t, then the current graph will be something like I naught sine, alright, omega t. Okay, it has shifted ahead, so minus del phi. So this is nothing but the phase difference. It could be plus or minus, doesn't matter. This is the phase difference between the voltage and the current. This is the phase difference. Sometimes the current can be ahead, sometimes the current can be behind, depends. So this is the phase difference. I hope this is very, very clear. Now, if this much is understood, let's also talk about why this phase difference exactly comes and how do you represent it. Now, remember, the phase difference can be represented on a phasor diagram. Remember phasor diagram from simple harmonic motion? I have told you about phase diagrams, guys. So, if I want to show the phasor of the voltage, you can choose anything, alright? You can choose anything. Let's say this is the phasor of the voltage, for example, and it is rotating with angular speed omega. What it means is that if you drop a perpendicular, okay, then this much length gives me the value of the voltage at that instant. So if this is, let's say for example, omega t, this will be V or V naught, let's say V naught, for example, V naught cos omega t. So it tells me the value of the voltage at that instant. So this is our phasor of voltage. So the projection, the shadow of it on the horizontal line tells me what is the instantaneous value of the voltage. As this phasor rotates, you will see the length of the shadow, the length of this projection keeps changing, hence the voltage also keeps changing. It could be sine, it could be cosine, doesn't really matter. Okay, the length of the phasor, this length is always the amplitude, keep this in mind. So this length is always the maximum value. Okay, so keep this in mind. Next thing up is, since this voltage and this current are not simultaneous, you will see that there will be some phase difference between them. So if this is voltage, this will be current, and you will see that there is some phase difference between them, and that is shown over here, that is del phi. So this is the phase difference between the voltage and the current. I hope this is very, very clear. Okay, and understand over here, I can say in this situation, if both of them are rotating like this, the current is leading the voltage by delta phi. Keep this in mind. The current leads the voltage by delta phi. That's the answer. So that's how you use phase diagrams, and that's how you represent phase diagrams for these curves. Another important thing that you should know is that if this is the maximum voltage and maximum current respectively for voltages and current, then there is a new term which we define called as the RMS value. So RMS value is the maximum value divided by root 2 for a sine or cosine term. So maximum value by root 2. Same thing, voltage RMS is V max divided by root 2. Keep this in mind. And remember, always in AC, the voltages, currents are usually specified in RMS and not in maximum. Keep this in mind. So when I say, okay, so when I say that, you know, for example, there is a washing machine or something like that, and I tell you it works at 220 volts, 50 hertz, please understand this is the RMS value. So the maximum value of voltage will be more. You can think maximum value will be root 2 times. So if one had to find max voltage, that would be nothing but 220 multiplied by root 2 at any instant. That's how it works. Keep this in mind. All right. So having said that, what is basically RMS? Let me tell you about that as well. So this is very important. If I tell you IRMS is I max divided by root 2, then what it means is that, okay, RMS current is that current in DC which will produce the same loss in heat as that in DC circuit. That means, think about it, if the current continuously varies and if you pass that current, okay, if you pass that current in a resistor, the heat which will be coming out will vary because the current is changing. So how do you calculate the energy loss? So what you do, instead of having varying current, what you do, replace this current with RMS current. With RMS current. Whatever heat will be produced by the RMS current will be the same heat produced by this variable current. That's the meaning of RMS. I hope this is clear. I hope this is clear. So RMS current is that constant current which when passed in a DC circuit produces same heat as that in the DC circuit and the AC circuit. Alright, so this is very, very important. Same heat will be produced in DC as well as AC. I hope this is clear. Hello Ensai, welcome, 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 welcome. Okay. So I'm not sure, Ankit, which graph is not visible. I think it's clear. This arrow mark is still this point. This arrow mark is still this point. The blue ones. Isn't it obvious? Okay, cool. Next up, very important thing. Power loss. I was just telling you about power losses. So let's talk about power loss. So for a DC circuit, okay, remember, for DC circuit, we know that the power loss is nothing but I squared R, correct? But you cannot do the same thing, all right, for AC circuits because the current is continuously changing. So what do? Very simple thing, very simple thing. All you need to do is in AC circuit, the power loss in AC circuit instead of any random I, use that RMS I RMS square into R. That will give you the power loss. Why will this give you the power loss? Remember, RMS is the equivalent. It is the equivalent DC current for the same power loss. Remember, RMS current is the same equivalent DC current which will produce the same power loss. So use IRMS square R. Correct. And there is another formula which you can use, and that is, I'm not sure how many of you know this. Well, the formula is VRMS IRMS. Yes, IRMS into cos phi, basically, or cos del phi, I would say. Depends how you, some books use phi, some books use del phi. It's up to you guys. So what is this phi? Remember, it is the phase difference between the voltage and the current. I just showed you that graph some time back. Voltage and current may not always be in same phase. It might not always be in sync. So it is a phase difference between the voltage and the current. So cos phi term will come. That is the strange part actually, which you should remember. So it is cos phi. Remember this. So it is cos of phi. So both the formulas are equivalent of each other. It depends which one you would love to use. If resistance is given, you will use this. If it is not given, then use this. And keep this in mind that this value, all right, cos phi is called as the power factor. So it is the power factor of that particular AC current and voltage which is there. Very, very important. Yes, this is the power factor. So what will be the maximum value of power factor, guys? Think about it. What is the maximum value of power factor that you can have? Can you guys think about it? Yes, come on, think about it. So if you're facing some buffering issue, I think yes, it's already been replied. Yeah, lower the video quality, it will definitely help you. No, it's not 6, it's 1. Yes, the maximum value of the power factor is 1 because cos has a maximum value of 1 and the least value is 0. Keep this in mind. Okay, magnitude wise. So let's get going to some problems. Very interesting question coming up on your screen. All right, so think about it. The equation of the alternating voltage applied to our houses is this much. 311 sine 100 pi t volts. There is a DC voltmeter which is used to measure the alternating voltage. The reading shown by it is how much? Very interesting question. Is it this, or this? Come on, note it down, take a screenshot if you want. Think about it. 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 Come on, 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 come on. Come on, minions. All right. All right, all right, all right. Come on, come on, come on, come on. Okay. Well, don't worry. I'll tell you the answer in a bit. For all the new users out here who are facing problems while studying, who have a lot of doubts and who want to practice a lot of problems, who are under stress and who are currently in the 12th standard or in the droppers batch or who have taken a drop for reappearing for the examination. All right, I know these are the common problems which most of the students are going to encounter, like there is hardly any time left and you don't know what is the structured way of studying. You don't know which are the important topics, you don't know how to study them, and sometimes some topics are weak and you want to at least make it average, or if I have an average topic you want some more problems on it and you want some test series. So don't worry guys, right? There is a solution for all of this and some of you already are enrolled in these solutions, and that is nothing but, you know, a detailed crash course for all of you where we are going to give you lots and lots, almost like 45 sessions, all right, where all the topics of 11th and 12th standard will be taught, 20 tests along with the discussions and doubt solving from morning till evening. That is very important. Doubt solving, you have a detailed plan right from 11th till 12th, and testing so that you know what your mistakes are and you improve upon them. And obviously the classes are live and they are also recorded so that you can watch it again and again if you face some difficulty. All of this, all right, all of this, like I was telling you, 15 full syllabus, 5 part tests, unlimited doubt solving from morning till night, getting your replays, and obviously the best teachers. I know them personally. All right, all of this in this crash course, which starts every Monday. All right, every Monday, and the link for joining this crash course is in the description box. Please check it out, open it up in a separate tab, read all the details. I would suggest you guys, especially if you're in 12th or a dropper student, think about it and join as soon as possible because the time is really running out. Not for joining just the crash course, guys, but even for studying. So there is hardly any time left. You should not leave any stone unturned for your preparation for the upcoming JEE Mains examination. So that's why I'm telling you. So if you want a structured way of studying, you want those test series and doubt solving, this is the only course available, and this is going to definitely be a life changer, a game changer in your preparation. Usual course price is 10,000, but the offer price is 8,000. Like you can see, 20% off if you use the coupon code SHCC21. So do not forget to use that coupon code. Unless and until you use that, you will not get 20% off. So please check it out, especially all the 2021 students out here. All right, now let's talk about the solution for the previous question. Guess what, guys? The answer is 0 volts. The 0 volts, because you have to read the question very carefully. Remember one thing, okay? Remember one thing. This is an AC circuit. It's an AC current. So the voltmeter which has been used is a DC voltmeter. So what will a DC voltmeter do? It will give you the value of the voltage at that instant. At that instant. So the voltage is continuously increasing, decreasing. So that voltmeter is going to fluctuate. But it's going to fluctuate so fast that it won't be able to even move. So you know what is going to happen? It's going to remain there. Because if you pass your normal current, which fluctuates 50 times a second, the voltmeter needle won't be able to move and it will stick there at 0 volts, which will be the average voltage. Remember, the average current or voltage of AC is 0. For AC circuit is 0. And that is the value which is shown by the DC voltmeter or ammeter. So the average value is always shown by the DC voltmeter. Okay, so keep it in mind. Don't worry, even if you got it wrong. So these kind of questions have been asked previously. So that's why I gave this to you. Next question. The RMS value of an alternating current, which when passed through a resistor, produces heat 3 times of that of produced by a direct current of 2 amperes in the same resistor. So the question is, what is the RMS value of that current? What is the RMS value of that alternating current? Come on, guys, think about it. You should get it. Saurav, you're a little bit late, but you can go back, rewind, and catch up at 2x speed. Do that. Very good, very good. Very nice. If the video screen is clear, thanks, VK. All right, so let's see how to solve this. Okay, if you want to do it on your own, yes, please go ahead. You can continue doing it. But those of you who need help, see how I am doing it. The current when passed through a resistor. Okay, so you have a resistor and this current is basically a varying current. Produces 3 times heat. Okay, this current produces 3 times the heat as that of a current of 2 amperes when passed through the same resistor. So think about it. What is the heat produced when a varying current passes through a resistor? AC current passes through a resistor. It is nothing but IRMS square multiplied by R, isn't it? And this is 3 times the heat produced by a DC current. What is the DC current? 2 amperes. And what is the power loss formula for DC current? I squared R. Understand that. So it will be nothing but 2 square into R. I hope this is clear. Now you know what to do over here. R and R will get cancelled. You can see R and R will get cancelled. And therefore you will have IRMS is equal to, take root on both sides, 3 into 2 square, which is 2 root 3 amperes. That should be the answer, which is over here, option D. Some of you got it correct. I think most of you got it wrong out there. Yes, Saurav, you got it correct. Very good, very good. Excellent. So guys, learn to visualize what is asked in the question. The question said the RMS current's heat is 3 times that of the heat produced in the DC current. What was the DC current? 2 amperes. Use your standard formula and remember the concepts. That's it. You will get the answer. That's it. Shall we go ahead, guys? Is this clear? Is this point clear? Okay, let's go ahead then. Let's get going. Cool. So, next question coming up. Yes. Cool. Let's go to the next question. And here it is. Yes, option was correct. 2007 question. In an AC circuit, alright, in an AC circuit, the voltage applied is this one. E is equal to E naught sine omega t. The resulting current in the circuit is I is equal to I naught sine omega t minus pi by 2. The power consumption in the circuit is given by. This was asked in 2007 previous year question, guys. Come on, think about it. What should be the correct answer? 2007 question. Let's see how many of you will be able to crack the exam if you are in 2007, giving it right there. Let's see how many of you could do it. Come on, Shreya says C. All right, I don't know. Come on. Come on, all the minions. What are you guys doing? Kirito says C. Yalni says C. Okay. Let's see whether the minions can make it through 2007 paper if you are writing it. Rihan Ali says C. Princey says C. All right. Science Priya also says C. Aishwarya says C. I don't know. Minions, have you guys ganged up or what? Anish also says C. Vasudevan says C. Well, looks like if the minions were writing the paper in 2007, will they crack the examination? Let's find out in the next slide. And it is correct. Very good, minions. Very good. Excellent. And the answer is simple. Why? Because the phase difference is 90 degrees. Look at that. This is sine omega t. This is sine omega t minus pi by 2 between voltage and current. And that means cos of delta phi will be 0. And recollect power loss. Alright, power loss was Vrms into Irms into cos del phi. So if cos del phi is 0, power loss must also be 0. That is the answer. Very good. Congratulations, minions. Excellent. Very good. Let's get going to the next thing. Yes, minions, I'm pretty sure you're going to also crack the 2020 examination. Believe me, you're going to do it. Okay, chalo, let's do the next question. Series LCR circuit. Now this is a very important part of this chapter. So pay full attention. Your focus should be here. Also keep making notes simultaneously. Now, the interesting part, when LCR are in series, you do not have parallel circuits. Please keep this in mind. Alright, some special questions come, but how to solve them, don't worry. I will teach you how to solve those kind of questions in a special problem solving class. First, let's get to the basics. If you have LCR in series across some external source, then the strange part is this voltage, and this voltage, which is measured across inductor, capacitor and resistor, is not going to be the same. Usually it is not going to be the same. And one thing is same though, because they are in series, the current flowing through all of them is going to be the same. So current through all of them is same. Voltage may or may not be the same. Also one more thing, the voltage across each one of them may not be in the same phase. Yes, the phase is not the same. Keep this in mind. Okay, and that's what we are going to see now. Let's start with the resistor. Focus all your attention on the resistor, nothing else. And let's see what exactly happens for the voltage across the resistor. So, if imagine this is VR naught. What is VR naught? VR naught, alright, is the max voltage, okay, across the resistance, alright. And I tell you, there is a current which is flowing, and that is I naught. And I naught, what is I naught? It's the max current, that is like the amplitude, guys. And the same current will flow through all of them, keep this in mind. Then here is what happens. If you draw the phasor diagram, the phasor of the current, alright, if it is over here, okay, this is the phasor of the current, remember, then the phasor, alright, the phasor of the voltage also comes out to be, okay, also comes out to be along the same line. So this is the phasor of the voltage. So what was it? VR naught. So this is VR naught. Keep this in mind. This is the phasor of the voltage and current. So basically the conclusion is the voltage and current in a resistor are in the same phase. Keep this in mind. And therefore I can also say V R naught is equal to I naught into R. That is standard. The voltage is current into resistance. Keep this in mind. All right. Yes. Very good. Guys, come on. I hope you have also liked the video. All the new timers, I hope you have subscribed to our channel, because then you'll miss out on many updates. Okay. So make sure you have subscribed and make sure you have shown all your love, support and energy through your likes as well. Do that. Now, yes. Don't worry, Saurabh, we are coming to that. Hold on. Now, keep this in mind. I hope you have made all the notes for this. Now, next up is, instead of a resistor, let's talk about inductor. The moment you have an inductor in the circuit, what happens? So, all our attention is over here on the inductor. Keep this in mind. All right. Now, let's say VL naught. What is VL naught? It is the max voltage. The max voltage across, okay, it is max voltage across what? In the inductor. And obviously the current flowing is I naught, that's the max current. Then again, if you draw, this is the current, say for example, this is the phasor of the current, okay, then you will see the phasor of the voltage across that inductor is going to come over here. This comes by calculations. For now, don't worry about it. This is VL naught and the angle is 90 degrees. Very important. And how do you remember L is on the top? Very simple. Remember this phrase. Love is above all. Keep this phrase in mind, guys. Love is above all. So love is over here. I hope this is clear. Everybody understood this? Thank you, Aishwarya. So you're going to study optics with the help of my lecture? Well, I'll tell you, just watch the playlist, read H.C. Verma, solve previous year questions. Wherever you find it difficult, watch the theory again and again and solve the problems. That's all. That's all you need to do to clear optics. All right? Cool. Thank you, Dinesh, so much. Love you too. Love you all the minions, in fact. Okay. So one more important thing. The voltage leads current by how many degrees? 90 degrees or pi by 2 radians. Now, here is a slightly different thing. If I have to find the relationship between voltage and current, alright, you will not get resistance here. You will get the equivalent of resistance for an inductor, which is XL. This is the important formula. Now you might be wondering, what the hell is this XL? This is called as inductive. This is called as inductive reactance. This is called as inductive reactance, and it is also expressed in ohms, by the way. This is the equivalent of resistance for an inductor. How much resistance does inductor offer? You can see V is IR. Instead of R, you have X, and X is reactance. Because it's for an inductor, I have put the subscript as L. And if you are wondering what is the value of XL, well, here it is. XL is omega L. Keep this in mind. XL is omega L. So omega is the frequency, L is the inductance. I hope this is clear. I hope this is clear. Yes, I hope this is clear. I hope all the minions are understanding this. So voltage leads the current, love is above all, keep this in mind. Current is always on the horizontal line. Voltage is current into reactance, and reactance is omega L. XL is omega L, XL is omega L, keep this in mind. Voltage is current into resistance or reactance or whatever it is. Okay, let's get going to the next set, and you have capacitor out here. All right, so for a capacitor, what happens? Again, VC naught. Again, what is VC naught? Max voltage across the capacitor, and obviously you have the current which is flowing through the circuit. Again, if you draw the phasor diagram, if this is I naught and this is how the angular frequency is shown, then the phasor for voltage across the capacitor comes below. So it is VC naught, which is going to be over here, and it is down here. So in this case, remember, the current leads the voltage in a capacitor. Keep this in mind. The current leads the voltage in a capacitor. Current is ahead of voltage. Current will always be ahead of voltage. That's how it is. And just like before, VC naught. Okay, VC naught will be I naught, but instead of resistance, you have reactance. But since it's for a capacitor, I'm going to put the subscript XC. Keep this in mind. Yes. And what is this? XC, like before, this is capacitive reactance. This is capacitive reactance, and the unit is in ohms, and the formula for XC is 1 by omega C. Exactly opposite. And it's very easy to remember. I'll tell you how. Capacitor comes below, right? So you can see omega C is below. For inductor, where was it? The voltage on the top. Remember, love is above all. So L comes on the top. Omega L will come on the top because voltage is on the top. Capacitor is below, so omega C comes below. So keep this in mind that way. I hope this is a very simple trick and you guys have understood and cracked it now. Shall we go ahead? Okay. So very simple trick. So that's what happens, guys. If you keep attending these sessions, you will get a lot of tricks, easy things to remember. All right. Cool. Let's get going. Okay. Now, if this much is done, obviously the next thing will be, how about all of them together? Yes, L, C and R together. Then what do you have? Let's have a look at it. It's not that difficult. Okay. First of all, what will be same through all of them? The same thing through all of them will be the current. So the current which will pass will be same. So first I will show the current horizontally, preferably. Usually the current is shown here. Okay. And yes, I can also show omega. Now let's talk about the voltages. VL, VC, VR. Let's talk about it. Remember, VR, okay, VR was here. Okay, VR not, VR whatever you want to call it. VL was here. Okay, VL was here. And VC was down there. Love is above all, L is on the top, C is below, R is over here. This is 90 degrees, this is 90 degrees. Now, the total voltage across all of them, remember this very, very important line I'm mentioning. The total voltage across all of them is not equal to VL plus VC plus VR. That is not correct. Remember, the voltages are not in the same phase. So when they are not in the same phase, you cannot just add them scalar wise. You have to treat them like vectors. We have done this in waves or in SHM superposition. Yes. So actually speaking, V bar is VL bar plus VC bar plus VR bar. So treat them like vectors and solve them for getting the answer. Keep this in mind. Yes, I hope this is clear. And then you will be like, okay, so when I act them like vectors, how do I act them exactly? Very simple. Get rid of these two vectors first. Why? Because they are in the opposite direction. So if one had to think about it carefully, you can see that VR will be here and the other vector which you will be getting is VL minus VC, isn't it? VL minus VC, whichever is bigger, I don't know. It could be this or it could be this. So this is VL minus VC. So think about it. This one will be the resultant of these two. So this will be V, this V out here. I hope this is clear, and your current obviously is still in this direction. This is the current. And think about it, this angle will be phi. So this clears your doubt, hopefully, that why is there a phase difference between voltage and current. You can see this is the net voltage. The net voltage across all of them will have some phase with the current. Keep this in mind. Yes. Yes. So Supratik, all the appliances around you, all right, everything has some inductance, capacitance and resistance. So every appliance will follow these rules everywhere around you. All right. I hope that makes sense. Now, if this much is clear, all right, what is the actual value of V? Think about it. The actual value of V is root of VL minus VC whole square plus VR whole square. All right. So this is nothing but Pythagoras theorem. VL minus VC whole square plus VR square. That's the total voltage across all these elements added together. Now, I'll tell you one very interesting thing. You will love this. Now, what is that interesting thing? Let me get rid of this. Let me get rid of this. Remember, just some time back, I told you voltage across resistor is current into resistance. Voltage across inductor is current into inductive reactance. Voltage across capacitance is current into capacitive reactance. Now, you might be wondering, what will happen if you take the total voltage? The total voltage will be current into equivalent resistance, which is called as Z. Yes, equivalent resistance, which is called as Z. And what is this Z? This Z is called as impedance. Impedance is basically resistance and reactance together. All the resistances and reactances added together gives you Z. But be careful, guys. Be careful. Z is not R plus XL plus XC. Remember, just like voltages are shown like this, same way, be careful. I can also show, this was impedance, okay. I can also show their resistances and reactances over here in the phasor diagram. This is actually XL, this is R, yes, and this is XC. Yes, this is XL, this is R, and this is XC. Keep this in mind. And the resultant of all of them is Z. Yes. So Z is basically the resultant of all of them. So all you need to do is again go with that triangle. That's it. You will get it. So you will have R over here, and over here you are going to have XL minus XC, and Z is going to be the resultant of all of them. So Z is actually root of R square plus XL minus XC whole square. Keep this in mind. I hope now things have become very, very clear in your mind. Understood, guys? Understood, everyone? See, current is always the same, but voltages and resistances need to be accounted for their phase changes. So that's all you need to do. I hope this is clear. Cool. Let's get going ahead. All right. Everyone clear about this? Okay. Cool. Yes, very good. Let's get going now to some problems. Okay, here comes the problem. Look at this. Think about it, how this has to be solved. Okay. Yes, I'm back. Yes. No. I had actually muted it because somebody had come. So I had to just open the door. Okay, cool. Let's get going. In the circuit shown here, the voltage across, it should be E and C respectively is 300 and 400 volts. The voltage across the AC source. Actually, I think there is a printing mistake. This should not be E, guys. This should have been L. Okay, it should have been L. So across L and C are 300 and 400 volts. The voltage across this E is how much? All right. Now, some of you are saying 300, some of you are saying 400, probably some of you are thinking probably 500, some of you are thinking something else. So let me tell you how this has to be solved. Use phasor diagram. Current is here. Think about it. The phasor of voltage for inductor will be on the top. The voltage across the inductor is how much? 300 volts. So 300 is on the top. Next up, the voltage across the capacitor is how much? 400 volts. So it will be here. This is 400 volts. So there is no resistor, correct? There is no resistor. So that means what? There is nothing else apart from these two vectors which need to be added. So what is the resultant of both of them? Obviously the resultant of both of them will be 100 volts below, and that should be equal to E. Think about it. Yes. So a lot of people thought it was 300 square plus 400 squares root Pythagoras. No, they are opposite. So 400 minus 300. That's why this question is tricky. I hope now you understood this. All right, cool. Let's get going to the next question. Okay, 100 volts is the answer. How about this? This was asked in 2016. A series LR circuit is connected to a voltage, okay, so and so voltage. It's a AC voltage. After a very large time, how does the current behave, or how does the current behave as a function of time? Option A, option B is here, option C is there, option D is over here. How does it exactly behave? Come on, think about it. Come on, think about it. This was asked in 2016. So let's see how many minions can crack the 2016 examination. Come on, minions. Can you crack the 2016 examination question? Let's see. All right. Kirito says D, Rehan says D, Mighty says C, Aishwarya says C. I don't know. All right. Now, I'll tell you what this question is. Shall I tell you what this question is? It's a play of words. They have unnecessarily worded it in such a way. They have put unnecessary things so that you guys will be confused. And that's what they intend to do. Actually speaking, it's a very, very simple question. It's a AC source. There is a resistance, there is an inductor. What will happen? The current will also be like a AC only. The voltage will also be like AC. There will be some phase difference. Nothing special. Nothing special. I hope this is clear. Yes, the correct answer is D. Lot of people thought the answer should be C. You might think, oh, it's LR circuit. That's why they have given L by R. Guys, it's unnecessarily given to confuse you. This will be true if it was not a AC source. If it was a DC source, then the graph could be a charging or a discharging curve. Now this is in fact discharging, understand. So in fact it would be a charging curve and it will slowly saturate. So none of them are correct, guys, understand, this will be the correct answer. And why will it decrease? Look at this graph is decreasing. Why will the current decrease? There is no reason for it. Okay, so current will constantly be there, it will be maintained. Okay, cool. I hope this is clear. Yes, steady state is infinite time, which is very large time, but that was not here needed here. For AC circuits, the steady state is achieved instantaneously. So, understand, for inductor, capacitor, resistor connected to AC source, immediately the voltages start varying as shown, like the sine curve or cosine curve. Okay, oops. Next question. In a series LCR circuit, resistance is given, impedance Z is given, then the phase difference between the current and the voltages. Come on, minions, let's see how many of you can do this. All right. Let's see how many of you minions are able to solve this problem in a series LCR circuit. Rehan says A, No problem, Princey, no problem. Okay, yes, Dinesh, you are correct. Come on, let's see. Some of you are saying A. Not sure. Is it because you saw the answer before? I just happened to flash the answer by mistake. I went to the next slide. But anyways, let's see what the answer should be. Resistance. Draw the phasor diagram. Always go with the phasor diagram. Resistance is 10 ohm. Impedance is the resultant of all of them. So understand Z. Okay, Z is how much ohms? 20 ohms. So Z is 20. Resistance is 10. Now, what is the phase difference between the current and the voltage? Very simple, guys. If current is here, remember the total voltage is I into Z. So in fact, the total voltage is also going to be over here in the direction of Z, and in fact this angle is going to be phi. Now if you have understood this, you know what to do next. Just complete the resistance triangle. You can clearly see from this triangle what is phi. How can you get phi? Cos phi. Cos phi is base divided by hypotenuse, which is 20, which is half. Therefore phi must be 60 degrees. That should be option A. I hope now it's clear. Okay, yes, Princey telling no cheating out there. Yes, yes. Chori, 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 pakdi gayi. Okay, let's get going to the next question. And here it is. The answer is 60 degrees. No problem, Dinesh. Hota hai. Okay, here it comes. 2015 question. A series LR circuit. Good question. Let's see whether you can do this. Is connected to AC source of frequency omega and inductive reactance is 2R. Resistance is R. Inductive reactance is 2R. A capacitor is also connected whose reactance is R, and it is added in series with that remaining inductor and resistance. What is the ratio of the new power factor and the old factor? Okay, let's try to visualize what the question says. Let's draw old and new scenarios. This was the inductor and the resistance. Okay, and what they have given is the inductive reactance. Okay, XL is 2R. Okay, now let's try to draw the phasor diagram, guys. That would make things very simple. Resistance will be horizontal, inductance L will be on the top, so L will be here, that means XL will be here, which is equal to 2R, obviously. So think about it, okay, the resultant of both of them, all right, Z will be here and this will be phi, isn't it? This will be phi. So you can guess what is the power factor over here, because if XL is 2R and resistance is R, what is the value of Z? It's not that difficult. Z will be root of R square plus 2R whole square's root. So that is just going to give you root of 5 into R. Now think about it. What will be cos of phi in the first scenario? The cos of phi in the first scenario will be base by hypotenuse. Remember, power factor, that's what they are asking. The ratio of the power factor. So the first time the power factor in the first case is basically R divided by hypotenuse, which is root 5R, which is 1 by root 5. I hope this is clear. This is our first scenario. Now in the second scenario, think about it. There is inductor, there is resistor, and there is a capacitor. XL is given to be 2R, resistance is R, XC, how much is it? XC is given to be R, you can see that over here. XC is R. Now again, redraw that diagram. Let's see how it's going to look like. Resistance is going to be here, XL, 2R is going to be here, XC has to be below because remember it's capacitance. Now this diagram is very similar. Capacitance should be shown a little bit smaller because it is having only R value, whereas inductive reactance is 2R. This is same as having R over here and R over here, isn't it? 2R minus R is R on the top. So guys, again think about it. Their resultant, which will be Z, that net impedance of that circuit, will be root of R square plus R square, which is root of 2R. Now, I think you would have understood that this is the new phase difference. So, what will be cos phi 2? What will be cos phi 2? Base by hypotenuse. Base is R, hypotenuse is root 2R. That means it is 1 by root 2. This is the new power factor. So what is the new power factor to the old one? New by old. So what is the new by old power factor? Isn't it very simple? It's 1 by root 2 divided by 1 by root 5. So hence it should be root of 5 divided by 2. Correcto. Rihan, 5/2's root, not 5/3. Be careful. Is it understood? Is it understood? So you have to solve the problem systematically. See how I approached. I thought from the basics. Okay, I did not get confused because there was so much of information and so many things were asked. I just went with the basics. I took 2 scenarios. For each scenario, I went on solving via phasor diagram, treated it like vectors. That's the crux of solving the problems in AC. If you understand that the best way to solve AC problems is vectors, that's it. You have nailed it. You can solve all the problems of AC circuits. It's all about vectors if you notice. Okay, so root 5 by 2, that's the answer. Let's get going to the next one. Now, remember, long time back, I have told you about LC oscillations. All right, yes, Pandu is back. And we have seen that a circuit which has capacitance and inductance only has, and if it is charged, it has charges which keep oscillating, and it is equivalent to a spring mass system or an oscillating pendulum where the energy gets stored from one side to the other side and keeps oscillating back and forth. So these two things are equivalent. That's what I told you. Yes. Now that is what we are going to talk about in resonance. Remember, again, this is all reminding you of previous things. In fact, I can go back and tell you. Yes, remember that omega for a pendulum or for a spring mass system is root k by m, but for a LC oscillation, remember k's equivalent is 1 by c and m's equivalent is L. So remember, k has an equivalent of 1 by C and mass has an equivalent of inductance. So that's how the equivalence goes, and you can get the angular frequency of oscillation over here. So basically omega is 1 over root LC, keep this in mind. So that's the angular frequency for LC oscillation. Now imagine you have an inductor, you have a capacitor, it has its own natural frequency. So what is this? This is basically the natural frequency of oscillation. Now, what if you force it? Remember, I have told you forced oscillation. If something has a tendency to oscillate, you can go and force it. But if you force it in the same way it wants to oscillate, that is, your forced frequency matches the natural frequency, then the oscillation will be very good. It will have a big amplitude, and that is called as resonance. If the body has a natural tendency to oscillate, let's say at 5 Hz, but you tend to oscillate it at 8 Hz, then it is not resonance. You are not matching with the natural frequency. But if it wants to oscillate at 5 Hz and you also push and pull it with 5 Hz, then it will have a good amplitude. That is called as resonance. Same way in electricity, who will be providing that external energy? Who is that external periodic force which can resonate this? That is nothing but your AC source. Remember, AC is varying voltages. So if you have an AC source over here, it may or may not resonate it depending on whether the frequency of the AC source matches with the natural frequency. So if you connect a AC circuit over here, if it matches, you will see a large flow of energy, large current flowing in this circuit, else you will not see that. So that's what is the next slide all about. Resonance. If you have a LCR circuit, this is your external source, which is the external force providing that energy. It will resonate at a very special value, and that is when the frequency of the source matches the natural frequency. So very simple, very simple. This is nothing but your external source, all right, and this is your system. This is your system, and the natural frequency is nothing but 1 by root LC. And if this frequency and this frequency match, then you will see it will have maximum current flowing in this circuit. Maximum current will flow. So at this particular value, understand omega n equals omega of that source. Now, when this happens, okay, very interesting thing. When this happens, keep this diagram in mind. Remember, I had shown you the phasor diagram. This was current, right? And this was voltage across inductor, or basically XL, and this was XC, and this was resistance. When resonance occurs, very interesting thing guys, XL is equal to XC. Keep this in mind. XL is equal to XC, and that is very easy to see why that will be happening, because XL is omega L, XC is 1 by omega C. So take omega over there, omega square will be 1 by LC, so omega is 1 over root LC. Look at that. Isn't it the same thing? So XL equals to XC at resonance. That means guys, the total impedance, the total impedance will be equal to R. XL and XC will cancel out each other. That's why impedance is equal to R. In fact, cos of phi, which is the power factor, will also be 1. So this is that power factor. Why is the power factor 1? Because phi is 0 degrees. Keep this in mind. All these things will happen. And lastly, the total voltage will be current into impedance, but impedance is R, so it will be I into R. So that is why this current is the max current, all right, and that current is given to be V by R. You can see that. So this is a very important slide again. Keep this in mind. Yes, very cute equation. Good, Dinesh. Let's get going now. Yes, cool. I hope you have written down everything about this. Guys, today is a one-shot session, so I might be extending this session till 8:30. I hope that's fine, because I want to complete this AC chapter for all the aspiring students in one shot. That's very important because the exams are nearing up. Okay, cool. Let's get going. Here is a 2013 question. When resonance is produced in a series LCR circuit, then which of the following is not correct? Be careful. Which of the following is not correct? Here are your options. Let's see how many of you get this. Please keep in mind, this is single choice. Only one option is not correct. Yes, thank you, Dinesh, reminding me. Yes, I'll have some water. Meanwhile, keep looking at the options. Thank you, VK. Okay, many of you are saying D, some of you are saying B, C. Hi, crack meet with Naveen. All right. Priyanka says A, Yalini says C. All right. Everything covered. Okay, so yes, it's a very good question, by the way. So current in the circuit is in phase with the applied voltage. Inductance and capacitance, capacitive reactance are equal. R is reduced, voltage across capacitance will increase, impedance of the circuit is maximum. Come on guys, you should be able to get it. Thank you, crack. Neat. Okay, so let's see how many of the minions are correct. And here it is. The answer is D. Oops, only Kirito got it correct, I guess. Oh, okay, no problems. So let's see why all other options are correct. The not correct option is this. Remember, you have to mark the not correct option. Okay, so let's see why each one of them is actually correct. See, current in the circuit is in phase with the applied voltage. Remember, it is in resonance. And remember, in resonance, what happens? I've just told you. The current and the voltage are in phase with each other. The phase difference is 0. Remember, I just told you. So that's why it is in phase, because phi is 0. That's correct. So A option is correct. Inductive and capacitive reactances are equal. In fact, that is something I just told you. XL is equal to XC because Z is equal to R. I just told you. So this is also correct. Resistance is reduced, the voltage across the capacitor will increase. Okay, so if R is reduced, what will happen to the voltage across the capacitor? See guys, in that phase diagram, this is VR, this is VL, okay, and this is VC. Now think about it, okay, think about it. If R is reduced, then why will the voltage across the capacitor increase? Think about it guys. Why will the voltage across the capacitor or the inductor increase? Think about it. If R is reduced, do you make sense out of it? Is it natural or is it not natural? Well, it's not. Okay, come on, think about it. What should happen? What should happen if resistance is reduced? If resistance is reduced, then come on, let's see which minion can give the answer. What will happen when the resistance is reduced? Because this is where many of the people got confused. This is where many of the people got confused. Come on. Think about it. Voltage, if R is reduced, the voltage will increase. Does it make sense? Yes, correct. If resistance is reduced, what will happen? Resistance is reduced, the current will increase. And if the current increases, what will happen? All the other voltages will increase. That's correct guys. So basically, if R is reduced, what will happen? The current will increase. Correct. And remember, voltage across capacitor or voltage across inductor is I into XC. So if I increases, what will happen? Voltage across capacitor will also increase. That's how the logic goes. Cool. So this is correct. So the only incorrect option is this, because impedance is in fact not maximum. It is in fact minimum. It is in fact minimum. Keep this in mind. Yes, that's the correct answer. Cool. Yes. Oh my god, PV is equal to NRT? No. Okay, next question. An inductance of 1 millihenry and a charged capacitor of 10 microfarad are connected across each other. The resonating angular frequency of the circuit. Come on, let's see how many of you get this. This is easy one. Come on, minions. I'll be solving it. Let's see how many of you get this before me. Inductance is given, capacitance is given, connected across each other. What is the resonating frequency? Some of you are saying B, some of you are saying A. My god, oh, it's the same person saying that. Alright, come on, minions. It's not that difficult, very easy calculation. Jaideep says C. Okay, so the value of omega is, remember I just told you 1 upon root LC. Just substitute guys, nothing else about this. Root LC, L, 1 millihenry. Milli is 10 to the power minus 3. Capacitance 10 micro. That is 10 into 10 to the power minus 6. This will make it 10 to the power minus 3, 10 to the power 1 will make it 10 to the power minus 2, 10 to the power minus 6 will make it 10 to the power minus 8. That will make it 1 upon 10 to the power minus 4, which will make it 10 to the power 4. That is the answer, and that should be B. Yes, woohoo, very good. Dinesh, Aishwarya, Vasudevan, Priyanka, finally got it. Yes, very good, very good, very good, very good. Amazing go, amazing go. Now, you know, when I talk about a very interesting thing like, you know, transformers, a lot of people love transformers. Hannah, have you guys watched the movies? Transformer series, very, very nice series. And I remember I sat in one Transformers ride, guys. It was in Universal Studios in Singapore. I mean, if you visit Singapore, you should go to Universal Studios and you should definitely try out the Transformers ride. It is super cool. It feels like as if you are one of those Transformers and you're fighting with, you know, you are like Optimus Prime. Yes, it's crazy. You should see that. It's too cool. Yeah, if anybody has gone over there, yeah, let me know. And if you are going to go, do visit Universal Studios. It's too cool. Now, and I asked some students, have you seen do watch Transformers? I don't know what they thought. And next day, what they did was this. I was like, man, this is literally literal. So these were some of the students watching Transformers. Anyways, so let's see what exactly is a transformer. By the way, this is an actual transformer. What does this do? It changes high voltage to low voltage or low voltage to high voltage. If the voltage, comes down, that is called as a step down transformer, and if the voltage goes up, that is increases, that's called as a step up transformer. Why would you need to step down or step up the voltage? Because it is proven fact that when the current passing is less through a resistance, then the losses are less. So what happens is, from the power station to your houses, the voltage is increased, so the current reduces, and if the current reduces, the losses are less. That's what they do. So voltage increases, current reduces, losses are less, but obviously you cannot have 20,000 volts coming into your house, right? So just before it enters your house, outside your house or in your society, you will have this transformer placed so that the voltages are brought down to decent levels for usage. Yes. Yes, okay. Yeah. Yes, guys, what do you think? Even the admin is really cool of JEE Enthuse, just like we all teachers are. All the people, all the team at Vedantu is really cool. Let me tell you about it. Yes. Cool. Now, for a transformer, keep this in mind. There is a primary winding. What happens inside a transformer? There is a primary winding. There is a secondary winding. The current from here goes like this, comes out. Then the current will reverse. It will go like this and come out. So the current will keep changing the direction, and every time the current flows, it will produce magnetic field. Isn't it? Current carrying wire produces magnetic field. Those magnetic field lines are forced to pass in this iron core. Why is it forced? Because iron is a ferromagnetic material, and recollect ferromagnetism. That's a property where it easily gets magnetized. It has good permeability, so it will attract all the magnetic field lines. So most of the magnetic field lines are going to pass through this, and they will cut or pierce through this blue coil like this. Yes, it will pass through the secondary coil. Now the moment it passes through the secondary coil, remember Faraday's law. Faraday's law, guys. So what will happen? That will create change in flux. The moment there is change in flux, it will create EMF. So you will have this EMF creating EMF in the secondary coil. And depending on the number of turns, you can either increase or you can decrease the voltage. Yes. Correct. So guys, the formula is very simple. Number of turns in the primary upon number of turns in the secondary is voltage of primary upon voltage of secondary. But we are not done yet. Usually the power which is there inside, that power which comes in, is equal to the power which goes out. Now power formula is voltage into current. So Vp into Ip is usually secondary, my bad, voltage in the secondary into current in the secondary. Now using this you will get Vp by Vs is Is by Ip. So for current the formula is Is by Ip. So this is something which you should remember. So if this is 100% efficiency, alright, if it's 100% efficiency, voltage into current is voltage into current out. That's all. Energy conservation. Yes. Very good, very good, very good, very good. Cool. Now keep this in mind and let's start solving some problems. And that's the last problem for today. Here it comes. Let's see how many of the minions can get this. The number of turns in the primary is 50 and in the secondary is 200. If the current in the primary is 4 amperes, then the current in the secondary coil is how much? Come on, come on, come on, come on. Very good. Yalini has taken the brain out. Very nice brain, Yalini. Okay. Kirito is a very good commentator of our class. Very good, Kirito. Srinidhi, everyone says A. Yalini, Vasudevan, Priyanka, Princy, Dinesh, Science Priya, Kirito, everyone is saying A. So let's see whether all the minions are correct. Very good, minions. Excellent. You guys are correct actually. So all you had to do is number of turns in the primary upon number of turns in the secondary is current in the secondary upon current in the primary. Some people forgot this formula and they got some different answer. Primary is 50, secondary is 200, secondary current I don't know, primary current is 4. That's it guys. 50 by 200 is 4, 4 cancels, so I secondary is 1. That's the answer. Correcto? Excellent. Boom boom boomer. Oh my god, Sanspriya, have you actually watched that ad? That's really cool. And by the way, some homework problems for all the minions out here. Do try this out at home problems. This is the first question, is there in the session PDF. It will be uploaded also in the description box as well as the Telegram group. The answer and the solutions are mentioned here. Don't look at the solutions or answers. Next question, again, options are given, answer and solutions are given over here. Don't look at it before you solve them. The PDF, notifications, important updates, etc. will come up on the JEE Enthuse Telegram official group. Please do not forget to join it. Also, remember to subscribe to the channel and also hit that like button for all the efforts I have been taking for all of you for free, guys. And those of you who really want to get their doubts solved and the test series along with live sessions and the recordings, also some material for extra practice of problems. Remember, the crash course starts every Monday almost, and you can definitely catch up all your syllabus, all that you wanted to revise at a very affordable price of 10,000 rupees, but take a discount of 20% guys, and you will get it for only 8,000 rupees. The next batch is starting on 8th of Feb. Do not forget and use the coupon code SHCC, which is there in the description link below. So go ahead, check it out, join as soon as possible. Do not lose out on time. There is very little time left. All right. Thank you, minions. Bye bye. Take care. Yes. Oh my God, they got a new name, Shreyas. Wow. Nice. Okay, thank you, Princey. Alright, bye-bye. Take care, guys. See you tomorrow for a very special session. Remember, the session is going to be very sweet and short. So if you come late, probably you're going to miss it and watch it recorded. So be there live tomorrow sharp at 7 o'clock. Bye-bye.